Good morning and welcome to UKZN Metric Intervention Program for Mathematics 1, Paper 1. We will look at the weighting of the content area first and thereafter select areas we shall be focusing on today. I am Dr. Don Mhlongo from the School of Mathematics, Statistics and Computer Science at UKZN. The program outline. I will show you the weighting of the content area first, and thereafter we look at Mathematics Paper 1 for November 2019. Here is the weighting according to the CAPS document. Algebra and equations, including the inequalities, they weigh 25 marks plus or minus 3. The patterns and sequences, 25 plus or minus 3. Finance, growth, and decay, 15 plus or minus. Functions and graphs, they weigh about 35 marks. Differential calculus, about 35 marks. And lastly, probability, about 15 marks. Now, from the weighting that you see in front of you, you will see that the sections that carry a big chunk of marks are functions, okay? The areas I will be focusing on today will be algebra and equations, and that is question 1 of your final paper. I will also look at functions and graphs because they carry a big weight, and usually that is question 4 and question 5. And lastly, I will do calculus and its applications, which will be question 7 and question 8. I will leave question 9, which is the continuation of the applications of calculus for today, and we'll continue with that next time. Now, this is the paper that I'm going to show you. Just the paper, everything on the paper, and thereafter we shall be starting working out the solutions for each question. Now, you will notice in paper 1, question 1, 1.1, the first question is the question that requires you to solve. Let me use another color here to underline. When you look at this question, you will see that it requires basic factorization. Now, when you look at the second one, I bet you can try and factorize. You will spend the whole day. So that one will require the quadratic formula. Now, we have said this section is about algebra and equations, including inequalities. You will see the inequality there. Now, the fourth one involves basic exponents, but in this case, we are dealing with sets, which are part of exponents. And thereafter, it will be solving simultaneous equations. Now, 1.3 is a problem that you are seeing now that you might not see for the next 10 years, because it is just it's a problem designed to test your skills now in mathematics. So you cannot say it belongs to factorization, it belongs to inequalities. No. So it's the problem that you can always, when you feel that you are not sure, just skip so that you will return to it once you have done all the problems you are comfortable with. Question 2, we're going to skip. Question 3, we're also going to skip. That's about patterns and sequences. And then we will focus on question 4, which is functions and graphs. Now, that is the problem that we shall be doing together, and I will talk more when we get to the problem, when we get to the actual solution of the problem. That is the continuation of question 4. When you look at question 4, you will see that it requires the skills that you have learned. But when you get to 4.7, it's not easy. That will require thinking, a lot of thinking. So such types of problems, I would advise that you leave them and you return them later. And then question 5 is about the exponential functions and exponential graphs. We will do that problem, or we will do that question as well. That is the continuation of question 5 based on exponential functions. Question 6 is on finance and growth and decay. We'll leave that for the next time. We're not going to do it today. Question 7 is differential calculus. Now, question 7 is mainly the theory together with the graphs, basic applications. And then question 8 is the application, but that is more involved. Now let's get to question 1 and start solving. That is question 1, which is based on algebra, equations, and inequalities. Now, the first that you have is an equation that requires basic factorization or basic factors. Now, when we factorize here, we're going to open up the brackets. Can I change the color to blue? We open up the brackets, and then we ask ourselves, x multiplied by x is x squared, so we're going to put x here. And here, we now need to put the factors of 6. The factors of 6, whose sum is minus 5, are minus 6 and positive 1. So we're going to put positive 1 and then minus 6 equal to 0. And then we solve. Therefore, x is either minus 1 or x is equal to 6. Now the next one cannot be easily factorized, but we can apply the rule, the quadratic rule. X is equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now that will our b is 3. We have got 3 squared minus 4 times a is 4, multiplied by c, which is minus 5, divided by 2 times 4. That can be simplified, and the answer will be minus 3 plus or minus the square root of 98 divided by 6. And that will give us, because we are required to round off the answer to 2 decimal places, we will have 3 plus or minus 9.9 divided by 6, which is equal to 1.15. We're using our calculator in this case, or minus 2.15. The next question, we are required to solve an inequality. The first thing that we need to do here will be to factorize. Now the factors, because that is the difference of 2 squares, the factors are 2x, 2x, 1, 1, minus, and plus, and that is less than 0. Now, a method that will make our life easy here to solve this inequality would be to draw a graph. Here I'm saying we need to draw a graph of y equals to 2x minus 1 into 2x plus 1. Now, if we are to draw that graph, we will get a parabola whose x-intercepts are minus half and positive half. Now you will notice, because our aim is to check, is to find out when is this graph negative. Because by saying 2x minus 1 into 2x plus 1 is negative, is less than 0, we mean it's negative. Now, when is this graph negative? You will notice that above the x-axis, your graph is positive, but below it is negative. So this graph, you will see from the graph that it is negative for the values of x that are between minus half and positive half. So I am going to write, change the color for the solution. I am going to write x in the middle and then put the less than, and here it's minus half up to positive half. Now what you must note here is that the 2 endpoints, minus half and positive half, and are excluded in our solution. That is the solution. Now the next problem is solve for x, where we have got sets. Now the first thing that I will do here would be, if you still remember the exponential rule. Now I'm going to write down that exponential rule. Oh, anyway, let me just combine these two under one root. We put the square root of 32 plus x into the square root of 32 minus x, and that is equal to x. And thereafter we can square on both sides. Square root of 32 plus x into the square root of 32 minus x. We're going to square the left-hand side and also square the right-hand side. Now, simplifying the left-hand side, we're going to get, please note that after this, the root will be removed, and then we will remain with that factor, which is the difference of two squares. So I will have 32 minus x squared equals to x squared. Then I'm going to take minus x squared, or transpose minus x squared, and get 2x squared on the right hand side, which means that x squared is equal to 16, and therefore x is equals to plus or minus 4. Now, that is not enough in this problem. We need to plug in the values of x back into the original problem. So what I am going to do here, I'm going to create another page because this space is not enough. Now, in this blank page, you will remember that we had the square root of, inside here, the square root of 32 plus x into the square root of 32 minus x. And that was equal to x. Now, if x is equal to 4, our left-hand side will be the square root of, inside the square root of 32 minus 4 into, plus 4 square root of 32 minus 4. And we simplify that, and we get 32 minus 16, which is the square root of 16, and the square root of 16 is 4. It's not plus or minus 4. It's always 4. Now, the right-hand side, when we plug in 4, we simply get 4. Now we try minus 4. If x is equals to minus 4, our left-hand side will be the square root of 32 minus 4. We are substituting here x by minus 4 into the square root of 32 plus 4. Like we did earlier on, we will get 32 minus 16, which is the square root of 16, and that is 4. Now, when we plug in minus 4 on the right-hand side, we will get minus 4. Now here, the left-hand side is not equals to the right-hand side, which means that x is equals to minus 4 is excluded. It's not part of our solution. Therefore, x equal to 4 is the only solution. All right, I'm going to save this screen for us to use later. Let's return to the paper. So here we can say that therefore x must be equal to 4, and that is the only solution. We are done with 1.1.4. We get to 1.2, the simultaneous equations. We are going to take the first equation, make y the subject of the formula, which gives y is equals to 12 minus x, and then we substitute. The first thing to do will be to call that your equation Roman figure 1, and you take that one, we call it Roman figure 2. So this one will be referred to as Roman figure 3. We substitute Roman figure 3 into Roman figure 2. Okay, so where there is y, we put 12 minus x, and then we simplify. 12x minus x squared is equals to 14 minus 3x. Take the left-hand side, everything on the left-hand side, we transpose that to the right-hand side. We will get 0 here, and then x squared minus 15x plus 14. Now we can factorize the right-hand side, getting x, and the factors of 14, whose sum is 15, are 1 and 14. Signs must be the same and both must be minus. Then x is equal to 1 or x is equals to 14. Now substituting in Roman figure in the third equation, substituting these values in the third equation, we will get y equals to 12 minus 1, which is 11, or y is 12 minus 14, which is minus 2. Now, the ordered pair that we have been looking for, which is our solution, are 1 is to 11 and 14 is to minus 2. Now, 1.3, I said, was a problem that was not easy to do. Although we are not seeing it, but I can take you back to where we began quickly, where we are considering the product 1 times 2 times 3 times 4 and so forth up to 30. And we are required to determine the largest value of k such that 3 to the power k is a factor of this product. Well, we can skip this for now and return to it later. So I'm going to continue with question 4 and return to this problem later. Okay. The graph that you have on the screen represents a parabola, f of x equals to x squared plus bx minus 3, and a hyperbola defined by g of x equals to a divided by x minus p. F has a turning point at C, and it passes through x-axis at 1 is to 0. Now the point 1 is to 0 is here. On the graph. D is the y-intercept of both F and G. And the graphs F and G also intersect each other at E and J. The vertical asymptote of G passes through the x-intercept of F. Right now, without doing any calculations, we can quickly write down the coordinates of D. D is the y-intercept of the parabola. The x value is 0, but the y value is minus 3. Okay. Now let's carry on with our problem. Determine the value of P. Going back to the first slide or to the previous slide, you will see that P belongs to the hyperbola. And the value of P should be, it's A. In this case, it should be x minus 1, which means that our P is equal to 1. And the reason why we're saying, or the reason why we're doing this is because we know that this line is defined by x is equal to 1, which is the vertical asymptote. Whilst we are on the screen, you are required to show that A is equal to 3 and B is equal to 2. Let's go back to, okay, let me quickly write down P because we know what P is. The value of P is equal to 1. Now going back to the previous screen, we are also required to find the value of A and B. Now you will see that the hyperbola passes through the point D, whose coordinates are 0 is to minus 3. Now if we sub that into g of x, g of x, in other words, we know that g at 0 is equal to minus 3. So that means that A over 0 minus 1 is equal to minus 3, which means that A is equal to 3. And then getting to B, again, we know that the parabola passes through D as well. So that means that we are solving for B. So it passes through D, it also passes through the point 1, is to 0. So f at 1 is equal to 0, meaning that when we sub 1 where x is, 1 squared plus b times 1 minus 3 is equal to 0, which means that b minus 2 is 0, and therefore b is equal to 2. So we go back to the screen where we need to put down our answers. So we have shown, because we said here g of x was a all over x minus 1, and then we said since g at 0 was minus 3, that meant a over 0 minus 1 was minus 3, and therefore a was positive 3. Now taking the other one, we said f of x was x squared plus bx minus 3, but we knew using that point C, which was 1 is to 0. Let me go back to the previous screen. No, it wasn't point C. It wasn't point C, it was just a point along the x-axis. It wasn't point C, so let me remove C here. We knew, or we know, that f passes through this point, meaning that f at 1 was 0, yes, 1 squared plus b 1 minus 3, 0, which means that b minus 2 is 0, and therefore b is 2. Okay, so that is how we calculated the values of a and also the value of b. Now calculate the coordinate of c. Now c, if we go back to our graph, c is the turning point of the parabola. Now, as it is the turning point of the parabola, its x value in the turning point is given by minus b all over 2a. Now it's minus b all over 2a, but our b is 2, and our a is 1. So when we simplify, we get, no, not minus 2, but minus 1. I'm sorry about that. We get minus 1. Okay, we need to calculate the y value. We need to substitute minus 1 into the equation of the parabola, getting minus 1 squared. Our b is 2. 2 times minus 1, minus 3. And that is 1 minus 2 minus 3. And finally, we get minus 4. So the coordinates of C are minus 1 is to minus 4. Now the range of f that will require that we go back to the graph and start everything from the graph F is the parabola. Now, as the parabola, it has got a minimum point. In other words, the parabola will not go down beyond that point C. And the y value at C, which we calculated previously, was -4. So the y value here is -4, which means that the range is the set of all values of y that are bigger or equals to -4. Now we need to write that formally in a set form. So the range, let me change the color first, back into blue. The range of F is the set starting from -4, and it goes on indefinitely. It's up to positive infinity. Now, we use a square bracket at the beginning because -4 is included. But we use the round bracket at the end because we cannot reach infinity. We cannot say that now the range is from -4 up to a specific number, infinity, because infinity is undefined. The next question: determine the equation of the line through C that makes an angle 45 degrees with the positive x-axis. Now, the equation of the straight line we're talking about should be mx plus k. I'm trying to avoid mx plus c because we're already using c. Now, the gradient, which is m for this straight line, is the tangent of 45 degrees. But the tangent of 45 degrees is 1. So that means our equation is x plus k. Now we need to determine k. Remember the coordinates of C. Let's go back to the previous slide. The coordinates of point C are -1 is to -4. So that is the point that we want to use. C is -1 is to -4. So we substitute this point, or where there is y, we put -4 equals to -1 plus k, and that means that k is -3. And therefore, our y is x minus 3. So that is the straight line we are looking for. The next question: is the straight line determined in 4.5 a tangent to F? Now, if you look at this straight line, the equation is y equals to x minus 3. The y-intercept for this line is 0 is to -3. And it also passes through the point minus 1 is to minus 4. And both these points, the parabola, the parabola passes through these 2 points. So the answer is no. Because the line cuts, or we can say it intersects, F at 2 points. Remember that if we talk about a tangent to a function, we are talking about a line that touches the curve at 1 point. Now, in this case, we say no, because it intersects, because the straight line intersects the curve F at 2 points. Now, 4.7, the function h of x equals to f of m minus x plus q has only one x intercept at x equal to 0. Determine the value of m and q. This problem is not easy. It is not easy even with me. So I'm going to skip that problem and return to it later when I get time. So that is the strategy that we always use when we encounter something, a problem that we feel we do not have a ready solution or a formula to use in answering it. So we get to the next problem. The figure is small. I tried to enlarge it, but I failed. But anyway, this is an exponential graph, and that point that you see there has 4 is to 16 as the coordinates, and it intersects the y-axis, and the coordinates there are 0 is to 1. Now determine or find the value of k. Well, f of x is kx, which means that f at 4 is 16, but f at 4 is k to the power 4, and that must be 16. Now 16 can be written as 2 to the power 4. So that makes us conclude that k is equal to 2. Now I am going to write down f of x right at the step. F of x is therefore 2 to the power x. The next question, it's 5.2, which is a sub-question of question 5. The graph is obtained, graph G is obtained by reflecting the graph of f about the line y is equal to x. Now determine the equation of G. Now if G is obtained by reflecting the graph of f about the line y equals to x, that means that the y value becomes the x value and the x value becomes the y value, meaning that if we are to rewrite f of x as y is equal to 2x, as we normally do when we represent functions, then G is a function defined by x is equal to 2 to the power y. Now, when we make y the subject of the formula, then we introduce logs and write y is the logarithm of x to base 2. So then here we're going to put y equal to logarithm of x to base 2. Thank you. Okay, the next question, that was 5.2. 5.3 just disappeared. Okay, and we have got 5.4 there. Let us go back to and check where 5.3 or what 5.3 is. We just go back to the original question paper. Okay. Now we are required to sketch the graph of g. That is the graph of the logarithm. Okay, let's go back to the question. Now, if you remember, that is the exponential graph. Now, to draw the graph of let's draw the straight line. Anyway, I'm not going to bother about sketching everything here, but we all know that we are required to draw the graph of log of x to base 2. Let's go back to our questions. Okay. All right. Now, in this sketch, we can draw the straight line first. That is y equal to x, and then we look at the reflection. Of our logarithmic graph. So that one is y equals to logarithm of x to base 2. Now the points. Firstly, the point which is 0 is to 1 is reflected about that straight line. And on the logarithmic graph, we have got 1 is to 0. And corresponding to 4 is to 16. We have 16 is to 4 on the logarithmic graph. All right. Now that is the graph of y is equal to x. Okay. I am going to re-sketch these two graphs in order to answer 5.4 and 5.4.2. The graphs that we have is the exponential graph first. And then the logarithmic graph. That is your f, and that is your g. Okay. Now the question is, find the values of x such that if you multiply f of x by g of x, you get a positive answer. F of x multiplied by g of x must be positive. Now we know that if you multiply a positive multiplied by a positive, then what you will get will be a positive answer. Similarly, if you multiply a negative and a negative, you will get a positive. Now, when we get to the graph, we would like to know when are the two both positive and both negative. Now the color I'm changing to red. You will see that above the x-axis, all the graphs are positive, and then below the x-axis, all the graphs are negative. Now we would like to see or find the region where both are positive and also both are negative. So that is 0, 1 is to 0. Now you will see that from here, from 1, both of these graphs are positive, meaning that for values of x that are bigger than 1, both graphs are positive. Now note that I am excluding 1 because at 1 the logarithmic graph is 0. So 0 is not greater than 0. So 0 is just 0. So that is the reason why I'm saying x must be bigger than a 1. But when are the two graphs negative? Yes, the logarithmic function can be negative. As you can see along this line, it is negative. But the exponential graph will never be negative. So there are no values of x for which the exponential graph will be negative. So x greater than 1 will be the only solution. Or in a set form, we can write our solution as 1. We must exclude a 1. We can simply write 1 up to positive infinity. And please note that we have got round brackets because 1 is excluded, infinity is unreachable, so it's excluded as well. Now getting to the second part, the values of x for which g of x is less or equal to -1. Now we must look carefully at the graph. When is the graph -1? So yes, when is the graph -1? Here the graph is 0. That is the x-intercept of the logarithmic function. And it should be 1 somewhere here. Now, we need to find the x value corresponding to this y equals to minus 1. That is the first thing to do. And then we can agree that the values of x that we are looking for belongs to this region. In other words, they should be between 0 and this value that we need to solve for x. So we go back to g of x. Our g of x is given by logarithm of x to base 2, and then we want to know what is the value of x when log of x to base 2 is minus 1. So this is simply x equal to 2 to the minus 1, and that is the same as half. So that means that the values that we are interested in that are such that g of x is less or equals to minus 1 are values between 0 and half. So our solution set then solution set is, we're not including 0 and then up to positive half. And that is the region that I've shaded by green that shows the solution. If you want to, you can simply write x and you say your x is between 0, you put a half there, but you put less or equal to, because half is part of the solution. That takes care of 5.4.2. Now, we are, for now, done with functions and graphs. We need to get to calculus. Okay. Now, the first question requires that we find the derivative from the first principles. The first principle is the definition. First principle is the same as the definition. Of f primed x. Now the definition of f primed x is f primed x is equal to the limit h approaches 0 of f of x plus h minus f of x divided by h. Now we need to substitute f of x. The limit as h approaches 0 of f of x plus h will mean where there is x, you put x plus h. So we have got 4 minus 7 into x plus h minus, and the brackets here are very important, especially when you will have a minus or a subtraction sign. 4 minus 7x divided by h. Now we simplify. The limit as h approaches 0, we remove the brackets. 4 minus 7x plus 7h minus 4 plus 7x divided by h. Now 4 and minus 4 is 0. Minus 7x plus 7x is 0. Now the only surviving term in the numerator is 7h, but that is divided by h. Now we simplify again the limit as h approaches 0. Remember that if you try to substitute h at this stage, you will get infinity, or you will get 0 divided by 0, which is an indeterminate form. So simplify that first, getting 7, and then you talk about the limit as h approaches 0. Now you will see that 7 is independent of h. So if h approaches 0, 7 will remain 7. Whatever h wants to do, 7 will just remain as 7 because it is a constant. So the answer is 7. No. Yes, I made a mistake. It's here. That I had a positive 7h instead of a minus 7h. Minus, minus, minus. And that is our derivative using the first principles. The next question is 7.3. Where is 7.2? I'm going to leave space for 7.2, but let us deal with 7.3 first and quickly. The derivative, dy dx. I'm differentiating with respect to x here. So that will give us 2ax because the derivative of a will be 0. Okay, I see where I've made a mistake. The next one is supposed to be the derivative of y with respect to a, not dy dx, because we've done dy dx in 7.3.1. So I'm removing that. When we differentiate y with respect to a, we're going to get x squared plus 1. Now let's go back to 7.2. I'm going to allow space here for 7.2. So which means that we will get it from the original paper. Let's go back to 7.2. Let me see. If it is here, then I can immediately write it down. Okay, I think 7.2 was y equal to 4x to the power 8 plus the square root of x cubed. Now you were required to find dy dx. Now the first thing that you need to do before you can start differentiating will be to rewrite y in exponential form. So that this will be x to the power 3 all over 2. Now you can start differentiating. Dy dx is equals to here, 4 is a constant, and then you can start differentiating x to the power 8, which is 8 x to the power 7, and here we have got 3 over 2 x to the power positive half, because half is 3 all over 2 minus 1. And then we simplify. 4 times 8 is 32. X to the power 7 plus 3 all over 2. X to the power half is the square root of x. So that was 7.2. Let's get to 7.4. 7.4 is the curve y equals to x plus 12 over x, and it passes through a point A whose coordinates are 2 is to B. B is an unknown which needs to be determined before we can proceed. Now you are required to determine the equation of the line perpendicular to the tangent to the curve. So this is actually perpendicular. This is a repeat, and we need to remove that. It's a perpendicular to the tangent to the curve at A. Now, as I've said, we must determine the value of B first. So if we substitute that, where there is y, we can put B, and where there is x, we put 2 all over 2. So that is 2 plus 6, which is 8. Therefore, the coordinates of point A are 2 is to 8. Now determine the equation of the line perpendicular to the tangent. First of all, the line that is perpendicular to the tangent is called the normal. A line that is perpendicular to the tangent is a normal. Now, both of them are straight lines. Tangent is a straight line, a normal is a straight line, meaning that their general formula, in other words, if you want to determine the equation, you will have to use y is equals to mx plus, let me continue using k instead of c. So it's y equals to mx plus c. Now, from the information that is given, we are able to determine the gradient of the tangent and hence its equation. But what is important is the gradient of the tangent. The gradient of the tangent, we call it mt, is given as the derivative dy dx. But what is y? In this case, we know that y is equal to x plus 12 all over x, which can be rewritten as x plus 12 x to the power minus 1. Now we are able to differentiate or find dy dx of the curve. Now the derivative will be 1 plus 12 multiplied by minus 1 x to the power minus 2, which is 1 minus 12 over x squared. Now we need to substitute the x value at a in order to find this tangent. Now the tangent, when x is equal to 2, is given by 1 minus 12 over 2 squared, which is 1 minus 12 divided by 4, and that is 1 12 divided by 4 is 3, and 1 minus 3 is minus 2. So that is the gradient of the tangent. But we are interested in the equation of the normal. So there is no need for us to find the equation of the tangent first. The gradient is enough. Now, for any two lines that are perpendicular, in this case, the tangent is perpendicular to the normal. We know that the product of their gradients, mt multiplied by mn, should give us minus 1. And hence, mn will be minus 1 divided by mt, and in this case we're talking about minus 1 divided by minus 2, which is 1 over 2. So that is the slope of the normal. Now substituting everything back to the equation. So for the normal, y is half x plus k. Now we need to substitute the coordinates of a. We know that y is 8 at a and x is 2, which therefore means that your k will be 8 minus 1, which is 7. So the equation, I would like to squeeze it in this little space here and say the equation will be half x plus 7. So that is the equation of the normal. And this will be the last question for the day, question 8. Which means that when I see you next time, I'm going to go back to those sub-questions that I did not do today. The sub-questions that you will normally reserve up until the end to save time. Now, here, question 8. After flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. The path that the insect crawled can be described by ht equals to t minus 6 into minus 2t plus 3t, minus 2t squared plus 3t minus 6. And h is the height above the floor, and time is t is the time in minutes. At what height above the floor did the insect start to crawl? Well, the first thing, when did it start to crawl? It started crawling when t was 0. So we are going to say it started crawling when t was 0. Now we substitute that in the formula. H0 is 0 minus 6 into minus 2 times 0 squared, 3 times 0 minus 6. Now when we simplify, we will get minus 6 multiplied by minus 6, which is positive 36. So that was the height we have been looking for. Now, how many times did the insect reach the floor? Now, if we say the insect reach the floor, what is the height? Well, the insect will reach the floor when the height is 0, which means that t minus 6 into minus 2t plus 3t minus 6 is equal to 0. So this is the same as t equal to 6 or minus 2t squared plus 3t minus 6 is 0, which means that 2t squared minus 3t plus 6 is equal to 0. Now, it's not easy for us to factorize, so we will use the quadratic formula. T is equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Let me write that c properly. We have got c. Now we substitute. We have got minus 3 plus or minus the square root of minus 3 squared minus 4 times 2 times 6 divided by 2 times 2. And that is 3 plus or minus the square root of 9 minus 2 times 6 is 12 times 4 is 48 all over 4. Now, when you simplify, you will get 3 plus or minus the square root of minus 39. Okay, let me write down the answer nicely here. Put t equals to 3 plus or minus the square root of minus 39 all over 4. Now that is not real because the square root of a negative number is imaginary. So there is no solution, no real solution. So it will only reach the floor at t. It will only reach the floor at t equals to 6. So to answer the question, how many times did the insect reach the floor? The answer will be once. All right. I think we will stop there for today. Thank you very much. Now, the useful tips when answering your question paper. You start with the easiest questions. The questions where you are able to remember quickly the formula to apply and also the method to use. So those questions that are difficult, leave them for a later stage, as I have done in this paper. And again, question 1 all the time is based on algebra, inequalities, and equations. So you are expected to solve. The first equation is the easiest of them all, where you need to factorize. The second one will be an equation that cannot be easily factorized, but you will have to apply the quadratic formula. And then the question that follows that will be a question that involves the inequality. Remember that graphical method that I used in answering that question, because that makes your life easy, and you can do that question and spend little time on it so that you can move to the next, to the following questions. I think for now I will have to stop there, and then I will see you next time. Thank you.